We're going to continue with this 1993 AP Calc AB exam, multiple choice part of the exam. We left off on number 20. Let R be the region in the first quadrant enclosed by the graph y is x plus 1 to 1/3 power. The line x is equal to 7, the x-axis and the y-axis. While the solid generated when R is revolved about the y-axis is given by what? Okay, so you should know how this looks. This is almost just like the cube root of x. How does the cube root of x look? Okay, cube root x looks very similar to square root x for positive x. Okay, so this guy is just shifted by 1 to the left, actually. Okay, so that's why I drew it like this, okay? Because when x is 0, it'll be a value of 1, okay? So technically it'll touch 0 over here somewhere, okay? Now, so once again, this is cube root x shifted to the left by 1. So in the first quadrant, it looks something like that, okay? We enclose it by the line x is 7. That's over here. X-axis, that's right over here. And the y-axis, that's over here. And we want to revolve this region about the y-axis, okay? What's the volume of the solid that's generated? Well, we can't easily do it with the disk Washer method. So we have to use the shell method here, okay? So the shell method is 2 pi integral r h dx. What is r? That's the how far it is from the axis of rotation, the radius. Remember, it's a shell and then a circular shell, and then you expand it out, right? Or you roll it out. So you cut it and you roll it out. That's how I think of it. H is the height. The height is just the function cube root of x plus 1. So it's 2 pi integral of r, as said, is x. H is the cube root guy, dx. Limits of integration are from 0 to 7. Okay? And that is, looks like choice B. And let me circle that. At what value of x does the graph y is 1 over x squared minus 1 over x cubed have a point of inflection? Okay, so point of inflection, that should signal second derivative. So this is y. We just use power rule. Y prime is minus 2 x to the minus 3 power minus 3 x to the minus 4 power. Okay, so we could simplify, but I didn't. I just chose to find the second derivative right away. Y double prime would be, we bring that power down, it will be 6 x to the minus 4th. We bring this power down, it will be minus 3 times minus 4 is positive 12, but we have negative here, so negative 12x to the negative 5 power. Okay. The technique to factor here is we always pick the smaller term, or the smallest, if there's more than that even. So x to the minus 5 is smaller than x to the minus 4, so we factor that out. And we can even factor 6 out. So I factor 6x to the negative 5. So here, the first term, we would be left with x. The second term, we're just left with negative 2. Okay? And we can rewrite it like in this form. Instead of x to the negative 5, I just brought it down into the denominator and made it positive. We set this equal to 0. So there are critical points at x is 0 and x is 2. Okay? So we do the second derivative test. We plug in some huge negative number. Would it be positive or negative? So huge negative number would make the top negative. Huge negative number on the bottom, negative to the 5th power would make it negative. 2 negatives make a positive. Okay? Plug in a number between 0 and 2, like 1. Top would be negative, bottom would be positive, so it's negative. Plug in a huge positive number in this interval. Top would be positive, bottom would be positive, so it's positive. Okay? So it seems like there are 2 points of inflection because the second derivative changes sign twice. But however, we know that x is 0 is not in the domain. Okay, so it's actually asymptotes there. Okay, it's not a point of inflection. So it's only at x is 2, so C. Okay, an antiderivative of this guy is what? Okay, so here, how do we solve this? if you can't even factor the bottom, so you can't do partial fraction decomposition, which you learned in BC. I don't know if they've learned it in AB this year, but what's a technique where we can make it factorable, completing the square? So let me write it as this integral first. When we complete the square, what do we get? So we make sure the x squared term has a 1 in front, which it does. We take the term in front of x, which is -2. We divide it by 2, which is -1. And then we square that, which is 1. So plus 1. Okay, but we have to make this equal, so we have to make a total of 2, so we have to add another one. Okay, and we can rewrite this as 1 over x minus 1 squared plus 1 dx. Okay, now this we can solve. If we let u be x minus 1, du is dx, so our integral becomes 1 over u squared plus 1 du, and this is just the arctan. Okay, so that's arctan of, what's u? X minus 1 plus c, that is e. How many critical points does the function this guy have? Let's find the first, so the answer key said there's a different way to do it, but I immediately think when it talks about critical points, let's find the derivative, which I also got the same answer. So let's find the derivative of f. Here we need to use product rule and chain rule, so I took the derivative of the first one first, so power rule 5, x plus 2 to the 4th power, that's here, times derivative of x plus 2 is just 1, and then this we left alone, plus derivative of this guy is, again, power rule 4, x minus 1 to the 3rd power, okay, and times derivative of x minus 3, which is just 1, and then this guy we leave alone. So this would be the first d second, this is the second d first, okay? We set it equal to 0, okay? We can factor out x plus 2 to the 4th power, okay, so that's what I did here, and we would be left with 5 times x minus 3 to the 4th here, and here we still have one of them, so that's here, okay? And then you can factor out x minus 3 cubed, so that's what I did here. So we still have one factor over here, and then here it would all go outside, so we're left with 4 times x plus 2 there, okay? And we can simplify this to 5x plus 4x, which is 9x, negative 3 plus 2, sorry, not negative 3, this is negative 15 plus 8, which is minus 7, okay, negative 7. So that's how I got 9x minus 7 over here. So we see that we have 3 critical points here. It's x is negative 2, x is 3, and x is 7 over 9. So 3 critical points. So the other method that the key says was just look at the multiplicity of the zeros. I feel like that you could do that if you're more comfortable with that, that's fine, but at least for me, when I see critical points, I immediately think derivative. Okay? F of x is this guy. F prime is, we just use power rule and chain rule. So f prime is what? 2/3 x squared minus 2x minus 1 to the 1/3 power times derivative inside, which is 2x minus 2. We evaluate it at x is equal to 0. So what do we get? We get 2/3 times minus 1 to the 1/3 power times minus 2. Okay, so we should get 4/3. Okay, because this would be -1. -1 times -2 would be +2. +2 times 2/3 is 4/3. Okay. This guy's the simple derivative. If you remember it, then that's great. It's 2 to x ln 2. That's C. Okay. If you don't remember it, you can rewrite it as in terms of E. That is totally valid too. Okay? Because you can rewrite it as 2 to the x is e to the ln of 2 So e to the ln of 2 to the x. That's not right, actually. We can rewrite it as something else, though, not this. Let me just cross it out. Okay, so what can we write it as? Oh, actually, no, that was correct. My bad. Because e to ln 2 to x, we can write it as e to the x ln 2. And this we know how to differentiate, right? It's just derivative of e is just e to the x times e to x, right? But you would need to chain rule, so it'll be times ln 2. Okay, so that's how you get this one more time. So this we can rewrite it as e to the ln of 2 to the x power. Okay, so the e and the ln would cancel, so you're left with 2 to x. Okay, we can pull the power out in front of the log, so e to the x ln 2. So if we differentiate this guy now, e to the x times ln 2, it's just what? E to the x times ln 2 times ln 2. Okay, this guy is just 2 to x, which we found in the beginning. So it's 2 to x ln 2. Okay, sorry for any confusion caused. That's how you can do it without remembering the formula. Because I always forget if it's multiply or divide. So sometimes I just do it the long way. Okay. Particle moves along a line so that at time t, where t is between 0 and pi, its position is given by this guy. What's the velocity of the particle when its acceleration is 0? So we need to find velocity and we need to find acceleration. Okay, so this is the position. Velocity is the first derivative. Okay, so we differentiate this. That's just what? 4 sine t minus 2t over 2. So that's just t. Okay, now we find acceleration. That's the derivative of the velocity, which is 4 cosine t minus 1. Okay, that's here, which is equal to 0. We want to set it to 0 because we want to find when it's 0, when acceleration is 0. So cosine t is 1/4. This is where you need a calculator for the first time. T would be 1.318, something like that. So you just plug in v of 1.318. So 4 sine of 1.318 minus 1.318. You should get 2.55. This is the first problem where you need a calculator, the scientific calculator. Function f is given by x cubed plus 12x minus 24 so this is talking about increasing, decreasing, so let's find the derivative. Okay, this is the function. We differentiate is 3x squared plus 12 by the power rule. This is always positive for all x, so that means f is always increasing since f prime is always positive. So that is C. Okay, this guy, okay, when it looks like something like this, same integral almost, but different limits and all that, it's probably a properties of integral question, okay? So let's let f be 13 to the x minus 11 to the x. Okay, if this is f, this is negative f over here. So instead of rewriting that whole guy, I just wrote integral from 1 to 500 f of x dx plus integral from 2 to 500 negative f of x dx, okay? So by properties of integrals, since we have, well, you can think of it as area. We have the area from 1 to 500. We want to subtract the area from 2 to 500. So what's left? The area from 1 to 2. Okay? And so we just integrate this guy. That's 13 to x ln 13 minus 11 to x over ln 11. We evaluate from 1 to 2, and this way you need a calculator again. You should get 14.95 almost. So that's B, okay? We have this limit as theta goes to 0, 1 minus cosine theta over 2 sine squared theta. Okay? Let's just plug in theta is 0. What do we get? We get 1 minus 1 on top, which is 0. We get 0 on the bottom, indeterminate. So what can we do? If you know L'Hopital's rule here, then it's quite easy. But there's a different way where you don't need L'Hopital's rule. You need to remember a trig identity. Okay, so here's the original problem. I know what the sine squared is equal to. sine squared, so this is where the trig interval section comes in. I don't know if they learned this in AB this year, but sine squared x is half 1 minus cosine of 2x. Okay. Actually, I did not use that. What did I even do? Okay, so, my bad. So this 2 I pulled outside, okay? And then I know sine squared is 1 minus cosine squared, okay? Why did I want to write it like this? Okay, because this I can factor to 1 minus theta, cosine theta, 1 plus cosine theta. And when I factor it like this, these can cancel. So left with half limit as theta goes to 0, 1 over 1 plus cosine theta. Now we can plug in theta as 0. Half times when theta is 0, this is 1, so this is another half. So it's equal to 1/4. Okay. Region enclosed by the x-axis, the line x is 3, and the curve y square root x is rotated about the x-axis. Was the following solid generated? Okay, you should know how square root x looks. Okay, so you should be able to sketch the region very quickly. Okay, so square x looks something like this. We're bounded by the line x is 3 and the x-axis. Okay, so this is your whole region over here. Volume of the solid generated, which axis are we rotating about? The x-axis, okay? So we draw a representative radius, r. The volume is pi integral of r squared dx by the disk method, okay? So this becomes pi integral from our regions from 0 to 3 in terms of x. What is r? What's this length? Is square x. So square x squared, that's just x, times dx. So this is pi over 2 x squared from 0 to 3. This is from the power rule. So that's just 9 pi over 2. Okay. If f is e to the 3 ln of x squared, then f prime is, so this is where the properties of logs come in. I think this is kind of what I did in the other problem, right? We can rewrite 31 as, I'll do even up here, e to the, remember when we have some constant right in front of the log, we can put it back in as a power. So e to ln of x squared cubed. So this is the same thing as e to the ln of x to the 6th power. Okay, and we can reduce to x to the 6th. As simple as that. So f prime is the derivative of x to the 6th, which is 6x to the 5th. Integral from 0 to root 3 of dx over square root 4 minus x squared. If you want to do trig sub, I don't know if they learned it in this year, you could do it, or you could recognize this as the arc sine. Okay? If you don't recognize it, you might have to do this to be able to recognize it. Because it's usually 1 minus x squared, right? So we can factor a 4 from both terms. That's what I did here. So 4 times 1 minus x squared over 4. Square root of 4 is just 2, so we can pull that out. So half, okay? So, and then we can put this as x over 2 squared. That's the same thing as x squared over 4. Hopefully you can see that. I wrote it kind of small. Okay, now we can let u be x over 2. Du is half dx. Half dx, that becomes du. And then u is x over 2. So this guy becomes u squared. And now this is arc sine. This should be more recognizable, right? Arc sine of u from 0 to root 3 over 2. Oh, by the way, I have to change the limits of integration because we made a substitution. 0, plug in x is 0, so u is 0. When x is root 3, u is root 3 over 2. Okay, so that's how I got those. Now, it's arc sine of root 3 over 2 minus arc sine 0. Arc sine 0 is just 0, so what's arc sine of root 3 over 2? That is pi over 3. Okay. dy dx is 2y squared, and if y is negative 1 when x is 1, then when x is 2, y is what? So let's first solve for y in this differential equation. So this is separation of variables. We move all the y's to one side, so I move this y squared to this side. I move this dx to the other side. All the x's on one side. Okay, so that's this, and then I integrate both sides. This is just minus 1 over y is equal to, here's this power rule, 2x plus c. Okay, we have the initial condition 1, -1. That's what it says here. So we plug it in to find C. Y is -1, so it becomes +1 on this side, and then is equal to 2 plus C. C is equal to -1, so this is our particular solution for Y. Okay, we don't need to write it as Y is equal to something because we're going to plug in again. When x is 2, y is equal to what? So we plug in x is 2, so it becomes 4 minus 1, which is 3, is equal to minus 1 over y. So y is equal to -1/3. Okay. Top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. Okay. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? Okay, so a good idea to sketch what's kind of going on. There's this 25-foot ladder here leaning against the wall. Okay, and it tells us that it's sliding down at 3 feet per minute. So I put, if this height is y, dy dt is -3. It's sliding down, so I put negative, okay? When the top of the ladder is 7 feet from the ground, so y is equal to 7, what is the rate of change of the distance between the bottom of the ladder and the wall? So if this is x, they're asking what dx dt is, okay? So we can easily find out what x is, okay, by the Pythagorean theorem. X squared plus y squared is 25 squared. So x, this you would need a calculator, unless you know this by head, x would be 24, okay? Now, to find dx dt, we need to differentiate this equation. So it'll be 2x dx dt plus 2y dy dt is equal to 0. Okay? We have x, we have y, we have dy dt. So we can solve for dx dt. So I plugged everything that we know in here. Okay? And then I just solve for dx dt, which should be, since I can divide the 2 on both sides, this would be -21. We move it to this side, it becomes +21, and we divide by 24, which is equal to 7 over 8. So D. Okay, this is the common related rates problem. And then last problem for this part of the video. If the graph of y is ax plus b over x plus c has a horizontal asymptote at y is 2, vertical asymptote at x is -3, a plus c is equal to what? So if there's a vertical asymptote at -3, that means the bottom should be x plus 3, because -3 makes it undefined. Now, when there's a horizontal asymptote at y is 2, they have this is a rational function, they have the same degree, so the asymptote is the ratio of the leading coefficients. So a over 1 is equal to 2, or a is equal to 2. Okay, so if a is -2, then c is what? 3. Then 2 plus 3 is 5. Okay, I'll call it apart here. It's a little short for this one, but I need to call it apart. Okay, so hopefully you found it helpful. Please like this video if you did, and please subscribe to look out for the final part for this exam. Multiple choice part of this exam.